Hello, everyone. This is Shiv. I'm a participant in the Kaggle 5-day AI Agents intensive vibe coding course, and I'd like to talk about the agent that I've developed, which I call the UTCI tracker agent. So, climate change is one of the biggest challenges of our lifetime, and one of its most dangerous effects is rising heat stress. In the tropical state of Kerala, India, heat related illnesses are steadily rising. For instance, my hometown of Palakkad consistently ranks amongst the hottest towns in India, frequently clocking temperatures above 40 degrees Celsius, along with extreme humidity. To protect public health, local healthcare workers have to monitor heat levels and allocate cooling resources. But they're spread too thin and they often lack access to granular weather data. Standard weather forecasts only cover broad districts and they ignore localized microclimates. Furthermore, complex physical comfort indices are very often locked away in raw GIS databases that frontline workers can't easily query. So, to bridge this gap, I built the UTCI heat stress tracker agent. So, in the back end, a daily data pipeline fetches high resolution meteorological data from the ECMWF model twice daily. So, once at 1:30 p.m. to measure the peak afternoon heat, and again at 10:30 p.m. the same day to check if the thermal comfort is sufficient for an average human being to cool down and recover it at night. Using the official thermophile library, we then calculate the Universal Thermal Climate Index, an index that combines temperature, wind, humidity, and solar radiation to estimate an approximation of the body's physiological response to heat stress. Then, using GeoPandas, we then map these grid points directly into Kerala's local taluks and districts and then save them into a PostgreSQL database. The conversational agent was built using Google's Agent Development Kit, the ADK, and the agents-cli tool. So it enables healthcare workers to ask questions in plain English, like which taluks in Palakkad had a UTCI above 38 degrees for the past 3 days. The agent automatically generates SQL queries to retrieve the data and it answers back in natural language. For visual analysis, it connects to a model context protocol chart server, MCP chart server, to render graphs directly into the chat window. The user interface was built using React, TypeScript, and Vite. Let's see a quick demo of this tool in action. So, as you can see, this is the agent chat interface. There is an initial introduction message that talks about what this agent can do and gives you a list of sample queries. Let's run this particular query. Plot a line chart comparing the UTCI values estimated at 10:30 p.m. for the Chavakad and the Kodangalur taluks in Thrissur district over the last 4 days and provide insights, if any. Let's see how this goes. Okay, there you go. So now you can see that it has generated a chart that indicates how Kodungalur seems to have a slightly higher UTCI values recorded for the past 4 days at 10:30 p.m. in the night. In terms of insights, let's see what it is saying. Uh, Kodungalur consistently records higher UTCI values compared to Chavakad. It indicates that Kodungalur retains more heat or it is experiencing less efficient nocturnal cooling. It also does a basic thermal comfort analysis, and it is also noticing certain fluctuations in the UTCI across the last 4 days. So, yeah, that was the UTCI tracker agent. This project was developed as the capstone for Kaggle's 5-day intensive vibe coding course. Big thanks to Kaggle for this opportunity to build with Google's Agentic tools. Thank you and see you.